Thank you all for still sticking around. My name is Arko Dasgupta. I'm a software engineer at Tetrate and a maintainer on the Envoy Gateway project.
Hi, everyone. My name is Alex Volchok, and I'm an active contributor to the Envoy Gateway project and a software development architect in SAP. In the last years, I'm focusing on cloud-oriented services, emphasizing high availability.
And today we'll talk about keeping Envoy Gateway on even when bad things happen. So today we'll explore a few failure scenarios that can exist in a distributed system involving Envoy Proxy, Envoy Gateway, and the Kube API server. We'll examine how Envoy Gateway, which acts as the control plane, it deploys various strategies to remain resilient in the face of these failures. Eric Brewer's CAP theorem teaches us that when network partitions exist, we must choose between availability or consistency. In Envoy Gateway, we've intentionally chosen availability over consistency. This design decision allows external applications exposed by Envoy Gateway to be reachable. It allows internal developers to push configuration without interruptions. And this significantly reduces the operational overhead for platform engineers. So before we dive deep into the failure scenarios, let's look at the role of Envoy Gateway. Let's take a classic workflow. On the top right, you'll see the internal users. They're platform engineers and application developers. They are talking to the Kube API server by applying gateway API resources like gateways and HTTP routes. Envoy Gateway now reads these resources when it receives notifications from the Kube API server. It'll read it, process it, and translate it to XDS. This XDS is now stored in the XDS server's cache. Based off this translation, Envoy Gateway may also create, update, or delete the Envoy Proxy fleet. This Envoy Proxy fleet is instantiated in Kubernetes using a deployment service and HPA. So importantly, Envoy Gateway also validates this configuration. So if it finds any error in the Gateway API resource, it'll flag it as an error condition in the resource status. This tells the internal teams that the configuration has not been accepted. So now, once the Envoy Proxy fleet has been instantiated, it tries to connect to the XDS server in Envoy Gateway, fetches the XDS configuration, and loads it in the data plane. Now the Envoy Proxy fleet is ready to handle traffic from external clients to the backend. Now let's look at 3 failure scenarios. Envoy Gateway may not be able to connect to the Kube API server, either because the network is down or the connection has timed out. There may be a bug in the internal resource translator causing a null pointer dereference. Or you may have a lot of traffic causing the Envoy Proxy fleet to scale, and which may overwhelm the Envoy Gateway, causing XDS timeouts. I'll now hand it over to Alex to talk about the failure scenarios in detail.
Awesome. Thanks, Arko. So one situation that can happen is that a pod that was elected for leadership in terms of the Envoy Gateway control plane all of a sudden fails. What we did in terms of the architecture and Envoy is to ensure that the leader pod is not going to be too much different from any other Envoy Gateway replica that is running next to that. And this essentially is focusing on the XDS cache. So whenever a user expresses its intent via Kubernetes API, all the replicas of the Envoy Gateway control plane will effectively reconcile the intent, ensure that the XDS cache is reflecting up-to-date desired state, and whenever a leader is going to crash, a replica will be able to essentially replace that leader in a way that won't be harmful to the Envoy Proxies data plane fleet. Let's take a situation that can emphasize this architecture. So imagine we have a situation like the Kubernetes API failure. Some of you may think that's something that's not happening too often. However, in SAP we have experienced such situations. And by the way, it can happen due to various reasons. If you decide on an architecture that, for instance, is utilizing hyperscaler availability zones, there might be an issue in one of the availability zones. Accidentally, the leader might be in this zone, and it will lose connectivity. So of course, because we have the leader in that zone, the leader will fail. However, the standby replicas will be able to assume leadership, ensuring XDS is available all the time, and the authoring intent of the user will be reflected soon enough without any severe impact. Sometimes the situation can be worsened. So not only that the leader lost connectivity, it can happen that all the pods running, all the replicas lost connectivity to the API server. And the way we actually program that to happen is that whenever the leader lost connectivity, the controller will be restarting. That's something normally that happens to controllers that lost connectivity in Kubernetes. They will try to restart and assume connectivity. Of course, that's not a good thing. However, the replicas, they will stay online. They will still have a consistent XDS cache, ensuring that whenever another unexpected issue happens, as for example, one of the proxies decides to scale up or a pod restarts, it can essentially obtain the routes and continue to function without any issue. So you can be assured that your data plan is going to function even if the API server for some time is going to be unavailable. Eventually, connectivity will be resumed, and one of the replicas will be able to assume leadership. And in practice, essentially, all the user intent is going to be read back from Kubernetes and reconciled. So xproc is something that you may want to use in order to extend the default functionality of Envoy. And one thing to keep in mind here is that whenever you're extending Envoy, you should also ensure that the parts that are extending your routes are highly available. We have ensured that you will be able to configure health probes and fallback services that want to back your xproc. And in terms of, so to speak, the business requirements, whatever you specify in the health probes will ensure that you will have sufficient enough fallback in terms of making the traffic continue to flow to your backends without the user experience too much of an issue. So whenever you are planning on using xproc or other things that extend your routes, always you should ensure to have a fallback in place and think what will happen if this component is actually not going to process the routes and function as you expect. Sometimes things actually can be planned. So whenever we are planning for Kubernetes upgrades, or we want to have something that's going to bring your nodes down and up, it's important to ensure that you know to have a guarantee for the capacity that's essentially will ensure your operations to flow as expected. With Envoy Gateway, we have allowed to express both for the control plane and also for the data plane for the Envoy Proxies, HPA policies that can ensure that you have sufficient amount of replicas to handle your authoring and also data plane needs. Sometimes traffic can spike. Normally it's good things. I don't know if you have an e-commerce website and more traffic coming because of a specific sales event or promotions, that's good. Sometimes it can be a bug that causes a lot of traffic to spike in. To reduce your on-duty alerts and also ensure that everything continues to work as expected, we allow you to also utilize HPAs to configure how your system is going to behave when this traffic spikes. So you can ensure to have metrics that are analyzed and scale up proxies as you need. And that's also true for the control plane. Sometimes we as contributors and developers for the Envoy Gateway project can make mistakes. We can essentially have a configuration that we are unable to read and it will panic. In Go, panics are fatal. We don't want your control plane to crash because of mistakes we did. And what we have done to improve on that is, first of all, we won't crash on such situations. We will have monitoring available for you based on metrics. So you can configure monitors based on metrics for panics, receive alerts, inspect those, correlate with logs that we also will publish. Hopefully it will contain enough information so that you can understand what's causing the issue. And with that, you will have probably an option to understand if it's a configuration that was recently added and causing the problem and fix it immediately. And of course, report it back to the community, and we will do our best to release a fix. Sometimes, as operators, we may accidentally configure something that is invalid or incorrect. With Envoy Gateway, we prioritize correctness, and we ensure that whenever there is a misconfiguration, the affected routes of the misconfiguration, and only them, will report back to the operator a status through the Kubernetes API, which can be expected and analyzed. You can understand what's wrong, and the users which are consuming those routes essentially will also receive a coherent response indicating that there is an issue with the route. And by that, we try to avoid situation of misconfiguration. Essentially, maybe there is a security that should be checked, and the route is, for instance, is accessible. It's not what we have meant. So situations that are unexpected in terms of the configuration, they will be prevented and reflected back to the operator and also to the route consumers. Of course, unaffected routes will continue to function as expected. We have more ideas and things that we would like to improve. And for that, back to you, Arko.
Thanks, Alex. So we still have some more work to do to make Envoy Gateway more resilient. Imagine a case where the platform engineer has set the memory limit for an Envoy Gateway pod, but the internal developers continue to push configurations, causing the memory usage to increase. You may miss an alert or catch it too late, causing the dreaded out-of-memory crash. So one way to solve this could be resource load shedding, where Envoy Gateway can stop accepting and caching resources once it hits a specific memory threshold, like 80%. There are probably some other great ideas out there, and we'd love the community to get involved. If you're interested or have a suggestion, please add a comment on issue 3860. So in summary, when bad things happen, Envoy Gateway tries to fail gracefully instead of failing hard. It picks availability over consistency, and it tries to keep the last known good state of XDS available in the XDS server cache so proxies can continue to connect to it. I also want to thank Alex and Lior from SAP who've actually built out a lot of these features. And not only that, they've also added a resilience test suite that's hooked up in the CI to avoid any regressions. That's all we had for today. We'll be at the Envoy kiosk this week in the Project Pavilion, so bring all your hard questions there. There are also some other great talks around Envoy Gateway this week. You have Katerina and Ryan talking about their journey with Gateway API and Envoy Gateway at Docker. You have Huabing talking about advanced security policies in Envoy Gateway. So yeah, that's all we had. Thank you.
Thanks, everyone.